So today, Academic Daddy will be teaching you everything you need to know with regards to solving trigonometric functions. You need to know that the derivative of sine x is cos x. The derivative of cos x is negative sine x. The derivative of tan x is secant square x. The derivative of cotangent x is negative cosecant square x. The derivative of sec x secant x is sec x tan x. And the derivative of cosecant x is negative cosecant x cotangent x. Notice that anything that has c always have negative. If you know that, let's solve the first question. First question is y, f of x is equals to 3x plus 4. I told you that y is the same as f of x. So y is equals to sine 3x plus 4. This is what we are given. Now notice that this is function of a function. We use chain rule because of the fact that I can see sine, the outer one, can see the inside one. I told you that whenever you have a composite function of a function, that what you use is the chain rule. So I'll say let u be everything inside 3x plus 14. Now let y be sine u. So that means that the derivative of u, the u in respect to x, is going to be equals to 3. I've told you that whenever you have a constant and a number without power, know that it's just the number. Whenever you have the derivative of a number, know it's just 0. You don't need it. So now the y in respect to u is going to be, if it's sine, the derivative is cos. It's going to be cos u. So that means I cos u, go for it. So cos u. So dy of the x now, we know that it's the same thing as du over the x times dy over the u. So solving this out, you now have that du over the x, du dx is 3, dy du is cos u. And remember that u is equals to 3x plus 4. If you still remember. So this is your final answer. This is your final answer. So today we are solving questions, trigonometric functions using chain rule. So let's move to the second part. They say y is equals to cos 5x minus 1. So solving this, I can use the simpler method, shortcut method, but we're just starting. I don't want you to get confused. So let u be equals to what is inside. Let y be what is outside. So the u over the x, the u in this way. You can never have the u, the z, or the u, the y here because it's just u and x you see. So if I know this, it's going to be just 5 constants. 1 here, 5 minus 1. It's the same thing. So this is minus. Now dy with respect to u, dy du is going to be cos. The derivative of cos is minus sine u. So that means that dy dx is simply going to be du over dx, du dx, which is 5, then times dy du, which is minus sine u. And this is something as minus 5 sine, and u is the same thing as 5x minus 1. So this is my answer. So moving on, I have y is equals to sine cube x. And I need you to know that anytime you have sine cube or sine square, is the same thing as having sine and the variable all cubed. I need to know this. So if you know this, it's now the same thing as saying that this is the same thing as let u be equals to sine x, and let y be equals to u cubed. So that I know that if that is the case, this is going to be the same thing as saying the u of the x is equals to sine x. Sine x is the same thing as minus cos x. Are you kidding me? Which one is minus? Please. This is the same thing as cos. Just cos, please. Cos. Painting. Maybe God wanted us to paint. So this is the same thing as cos x. Anytime you see s positive, anytime you see c, the derivative of c is what will be negative. So this is s, the derivative is cos x. Now for dy du, this is going to be 3u square. 3u square. And notice that this u here is the derivative of u here is more or less sine they are talking about. Know it. So the derivative of u here, this u that we have here, the derivative of u here is a sine that is inside it. And you know that if you have this to be sine square, if you have this to be sine square, and I have this to be 3. So you know that this is sine square. So this is the same thing as having this. So when you want to get your dy of the x, the y of the x is now the same thing as du over the x times dy over du, which is the same thing as du over the x is cos x times dy over du is the same thing as 3u square. So this is the same thing as saying 3 cos x u square. And we know that if this is the case, that u here is sine square. So this is our answer. 3 cos x sine square. Can still do it this way if I want to show you. So for the moving on to the fourth one. So I've gotten, sorry, this is question 15. If you have the question, this is question 16. And this is question 17. Question 17. So we are moving to question 18 now. Question 18. How come question 18 and question 17 is looking the same? So let's move to question 19. Sorry. Question 19. We have y is equals to 3 tan square x. So it's the same thing as saying let u be equals to, know that this is the same thing. First of all, write this, the same thing as 3 tan x all squared. So this is the same thing as saying let u be equals to tan x and let y be equals to 2u squared. So the u over the x is equals to tan x. The derivative of tan is sec square, then there's x there. So this is the derivative. Now dy of the u is going to be the same as these two come over, it becomes 4u. 2 minus 1 is 1. So u is raised to power 1, and anything raised to power 1 is the same thing. So dy of the x is simply this, everything here times everything here, du over du dx times dy du. So this is the same thing as sec square x times 4u, and this is the same thing as saying 4 sec square x u. And you know that this is the same thing as saying 4 sec square x, everything inside the bracket for u is tan. U is tan x. So this is our answer. So this is 4 sec square x tan x. This is our final answer. So there you go. Please like, subscribe, and share.